So this limit is from Reddit. It's very interesting. Let's have a look. We are given that this limit here is equal to 12. And based on that, we are going to find out the derivative of f at 2. How can we do it? I'm going to show you guys the L'Hopital's rule later, not now, okay? First, we are going to be using the definition of the derivative. So let me remind you guys this right here. If today we have some function and then differentiate that at 2, this right here is equal to the limit. You can write x approaching 2 or h approaching 0. Here, as you can see, we have x approaching 0. So I will be using the one that approaches 0, which is the h approaching 0. In that case, you have to write f of 2 plus h and then minus f of 2 over h. And in fact, this right here is also equal to the limit h approaching 0. What you can do is, this right here is just like when you approach 2 from the right, because you're just adding h. Just think about it like that. You can also go from the left. If you have f of 2 first, and then minus f of 2, you see how the order got switched? But instead of adding the h, right here, you will have to minus h, and then O over h. This and that, they are both equal to f prime of 2. So keep that in mind. So how exactly can we continue though? It looks like we have the 2 already. This is the plus h, and here we have the minus h. So we are missing this, missing that, right? And the first thing is that we should put h to be 3x. Here we go. I'm going to say let h equal to 3x. And then notice here we have an x on the bottom. So let's divide both sides by 3. X is equal to h over 3. Now keep in mind though, if x is approaching 0, h will also be approaching 0. Now let's rewrite this limit in terms of h. We will have the limit as h approaching 0, and then here we have f of 2 plus h minus f of 2 minus h all over x, which is h over 3. And that is equal to 12. This right here stays the same. Now, to continue, what we have to do is just somehow break this down into that and also this, and then we can figure out what f prime of 2 is. That's the idea. Perhaps let's simplify the h over 3 on the bottom first. And we can do so by multiplying the bottom by 3 and then the top by 3, like so. So this and that cancel. So we can put a 3 to the front because limit is linear. And then we have the limit as h approaching 0. Now, for this, I really want to pair out with a minus f. For this, I really want to pair out with minus f of 2. So I'm just going to write it right here, f of 2 plus h, and then let me just minus f of 2. Can we do that? Kind of, as long as you add f of 2 afterward. So that's just adding 0. And this is good, because next we have the minus f of 2 minus h. This right here will be helping us for that. Perfect, right? Now, every body is divided by h. We can separate it. This right here divided by h, and then this right here divided by h, all together like this, and that is equal to 12. How's that? Pretty good, huh? Now, as you can see, if you divide both sides by 3, you can get this right here being equal to 4. Now, this whole portion, if you take the limit of the first, you get precisely f prime of 2. And then you add this right here, when you take the limit as h approaching 0, you also get f prime of 2. And of course, if we divide both sides by 3, this is equal to 4. So 2 of them equals 4. That means one of them is equal to what? Just 2. And that's it. Yeah, it works like that. You want to see L'Hopital's rule? Sure, let's go ahead and do it. I don't really think that you should be using L'Hopital's rule for this though, but I'll show it to you guys anyway. Here, let's write down the limit as x approaching 0. I should have mentioned if you plug in 0 into all the x's, on the top is 0, on the bottom is 0. So I'm just going to rewrite this again. And this is still equal to 12. When we have 0 over 0, we can do L'Hopital's rule, and we can just differentiate the top, and then differentiate the bottom. But seriously, don't do it. This is not really a beautiful solution for this particular question. Anyways, differentiating f of this is just f prime of this, right? 2 plus 3x. But remember the chain rule. Multiply by the derivative of the inner function. The derivative of 2 is 0. The derivative of 3 is a 3. Continue, minus the derivative right here is f prime, and then the inside, and multiply by the derivative of this. The derivative of negative 3x gives us negative 3, so that becomes a positive 3 over just 1, and this right here is equal to 12. Now, put 0 into here and here. On the top, we are getting 3f prime of just 2 plus another 3f prime of just 2. That's equal to 12. That means 6f prime of 2 is equal to 12. You can deduce that, or deduce. You can reduce that to f prime of 2 is equal to 2. And then we are done.